In 9.4, we're learning about our third conic section, which is ellipses. All right, so I won't read everything in this table. Now, one thing that our book does a little differently is, if you see what I wrote here in blue, for vertical ellipses, they change the order. So if it's vertical, they'll put the fraction with the y first. And then the way you could tell it's vertical is whoever has the bigger denominator. So if the denominator for y is bigger than the denominator for x, then it's vertical. If the denominator for x is bigger, then it's horizontal. A will always be bigger than b for ellipses. All right, so for the first three, we're given the graph. And so first thing we have to do is figure out, is it horizontal or vertical? Now, you have to be careful here because the scale is different. So from the center, and I don't think we need the midpoint formula. I think it's pretty clear that the center is 0, 0 for this one. Okay, so to go from the center to either the left end or the right end, doesn't matter, just not the whole way across, that distance is 11. And from the center to either the top or the bottom, that is a distance of 3. So because the distance is longer going left or right, this is a horizontal ellipse. And so we start with x squared. And I don't need parentheses because it's centered at 0, 0. All right, so it's going to be x squared and y squared in our numerators. And for standard form for an ellipse, you always want a 1 on the right side. And if there's not a 1, then you want to divide to make it a 1. All right, and again, the distance from the center to the end on the left was 11, so we square 11 to get 121. All right, the distance from the center to either the top or the bottom, that was 3, so we square that to get 9. All right, number 2 is vertical, and it is also not centered at 0, 0. All right, so the center of 0, 5 and 0, negative 1 is 0, 2. All right, so I'll write up here that our center is at 0, 2. And now if I count the two distances, this is 3, but this is only 2. So because it's longer vertically, we know it's a vertical ellipse. All right, so I'm going to start with y, and I need parentheses for the y because the y coordinate for the center is 2. So I do y minus 2. All right, from the center to the top was a distance of 3, so we need a 9 under there. Square the 3 to get 9. All right, I don't need parentheses for the x because it had a coordinate of 0 for the center. And underneath x, because this is 2, we square that to make 4, and we equal it to 1. All right, number 3 gives the foci. Number 2 also did, but we didn't need them, but we're going to have to use the foci. All right, so let's talk about the definition of an ellipse really quickly. So on an ellipse, you have a bunch of points. You have infinitely many points. There's a point here, there's a point here. Let me change the color. There's infinite points on the ellipse. And so the definition of an ellipse is, if I choose a point and then I find the distance to one of the foci and then the distance to the other foci, that sum is always the same. So if I pick another point on the ellipse, let's say right here, and if I find the distance to the two foci, that sum is always the same, and that sum happens to always equal 2 times a. All right, so the foci are given, and the foci are always on the major axis. We'll talk about major axis a little more when we get to number 4. All right, so clearly number 3 is horizontal. If you do the midpoint formula, you get that the center is at -1, 3. All right, so horizontal, centered at -1, 3. All right, so our first numerator is going to be x plus 1 squared. And from the center, I'll go to the right this time, to the end is 5. So we square 5 to get 25. All right, the y coordinate for our center was 3, so I do y minus 3 in parentheses. And then from the center to the top is a distance of 3, so I square that to make 9. All right, so we actually could have solved that problem without those foci being given. All right, so I guess we'll talk more about the foci when we get to number 6. All right, so number 4 talks about the major and minor axis. Let me go back to the ellipses at the top. The major axis is the longer one out of this line segment and that line segment. So the shorter one is the minor axis and the longer one is the major axis. So going over here, notice the vertical one is longer. So on this one, our major axis is that vertical line segment and our minor axis is that horizontal shorter line segment. All right, so looking at number 4, try to visualize where -9, 0 and 9, 0 are. Or you don't have to visualize it, you can kind of make a rough sketch. So -9, 0 and 9, 0 are side by side. So because those 2 points are side by side, and because they are on the major axis, we know this is a horizontal ellipse. Also, it's pretty obvious that the middle of -9, 0 and +9, 0 is 0, 0. So we know it's horizontal. We know it's centered at 0, 0. So we can start with x squared, and we don't need parentheses, so our numerators are going to be x squared and y squared. All right, from 0, 0 to either -9, 0 or +9, 0, that is a distance of 9. We square that to make 81. All right, your minor axis would be only 3 up and 3 down. So your ellipse would look like this, something like that. And because from the center to the end of the minor axis is 3, we square that to make 9. And then we end with a equals 1. All right, number 5. The length of the minor axis is always equal to 2a. So if the major axis is 10 units long, then 2a equals 10, which means a equals 5. The minor axis has a length of 2b. So if the minor axis is 6, then 2b equals 6 and b equals 3. All right, we are also told that the minor axis is parallel to the x, which means the major axis is parallel to the y. And if major is parallel to y, then it's vertical. All right, using the given center and knowing that it's vertical, we're going to start with y. All right, so if my y coordinate is -4, I do y plus 4. All right, we know that a is 5, so a squared is 25, plus, all right, x minus 2 squared. And we know b is 3, so b squared is 9, and we equal this to 1. All right, so now we're going to talk about the foci. So we just used the fact that from the center to the end of the major axis is a, from the center to the end of the minor axis is b, All right, those have a midpoint or a center of 0, 0. All right, so I can see already that B is 2, because from center to the end of the minor is B. And then what we haven't used yet is from center to foci, that is C. So from 0, 0 to either of these, that's a distance of 4. And so the way A, B, and C are related to each other, it's similar to the Pythagorean theorem, but instead of a squared plus b squared, it's a squared minus b squared equals c squared. All right, so we don't know a squared. We know b, so that makes b squared 4. We know c is 4, so c squared is 16. All right, so we end up with a squared equals 20. And I'm going to leave it like that, and here's the reason why. All right, so first we should figure out, is it horizontal or vertical? So because if I make like a rough sketch, the minor axis points are here and here. The foci are over here and over here. And the foci are always on the major axis. So the minor axis, those are vertical from each other. The points on the minor axis are vertical from each other. That means the points on the major axis are horizontal. So we have a horizontal ellipse centered at 0, 0. So we start with x squared. All right, and then equal it to 1. We knew b very early, so we knew b squared was 4. Now we didn't know a squared until we solved for it, and we never needed a by itself. We only needed a squared, and that's the reason I did not square root both sides over here. All right, on the back, we are given an equation. We need to find the center, the foci, the length of the major axis, length of the minor axis, and then graph it. So we have to find 5 things. All right, so there are no parentheses in the numerators, so our center has to be 0, 0. All right, next thing we need are the foci. So remember that the equation relating a, b, and c is a squared minus b squared equals c squared. All right, so a squared is your bigger denominator, b squared is your smaller denominator. All right, so we know c squared equals 7, so c equals radical 7, or plus or minus 7. All right, foci are c units away from the center. Now you have to be careful deciding whether to give that to the x-coordinate or the y-coordinate. Because this is vertical, and I know it's vertical because y has a bigger denominator, I'm going to give the c to the y-coordinate. All right, so I'm going to write it as 2 separate points. One foci is at 0, rad 7, and the other focus is at 0, comma, negative rad 7. All right. Now we need the length of the major and minor axis. I'll just write major. All right, the length of the major axis is 2a. So if this is a squared, then a is 4. So 2a is 8. All right, the length of the minor axis is 2b. All right, so here's b squared, which makes b 3. So 2b is 6. All right, and now we just have to graph it. So looking at the numerators, the center is at 0, 0. All right, underneath y squared, there's a 16. Take the square root. Square root of 16 is 4, so we go up 4 and down 4. Underneath x squared is 9. Take the square root. Square root of 9 is 3, so we go left 3 and right 3. And then we try our best to make an ellipse that goes through those 4 outside points. All right, next one, center. All right, so go to the x first, 3, 1. All right, for the foci, we have to figure out what c is. So a squared minus b squared equals c squared. 36 minus 1 equals c squared. So c, I'm going to skip a step, c is radical 35. And because it is vertical, I'm going to give that to the y coordinate. So I have 3, and now I give the c to the y coordinate of the center. And I also subtract it. All right. Major axis is 2a. All right, so if a squared is 36, that makes a 6, so 2a is 12. Minor axis is 2b. All right, there's b squared, which means b is also 1. So b, or 2b is 2. All right, center is at 3, 1. Because the graph counts by 2's, 3, 1 is around there. All right, underneath y squared, we see a 36. Take the square root. So we go up 6 and down 6. Underneath x squared, we see a 1. The square root of 1 is 1. So we go left 1 and right 1, and we have a very skinny parabola. Sorry, not a parabola, an ellipse. And you can see from the graph that the major axis is 12 units long and the minor axis is 2 units long. All right, x has a bigger denominator, so this is a horizontal ellipse. -4, -3 is our center. I'm going to go ahead and graph that right now. All right, the foci. All right, so I'm going to do a shortcut. For the foci, you just subtract. You subtract. You take the big denominator minus the small denominator, you get rad 24. Actually, you get 24, so c squared equals 24, and then c is the one that's radical 24. And radical 24 is the same thing as 2 rad 6. All right, and because this is horizontal, I give the 2 rad 6 to the x coordinate. And my other one would be the same thing, but minus the 2 rad 6. All right, my major axis, look at the 49. Take the square root, you get 7, and then double that, 14. For the minor axis, look at the 25. Take the square root, that's 5, and now double that, and you get 10. All right, so underneath x squared, there's a 49. Square root of that is 7. So I go 7 to the right and 7 to the left. Underneath the 25, or underneath the y squared is a 25. Square root of that is 5. All right, so up 5 from the center and down 5 from the center. All right, make my ellipse. All right, and then finally we have a word problem. We have an ice skater, 2 congruent ellipses to form a figure 8. The center of the first loop is at the origin. All right, center of the second loop is to its right. All right, so I'm going to make an x and y axis, but with extra room on the right. Write an equation to model the first loop. If it's major axis, all right, major is along the x, so that means it's horizontal. All right, so major is along the x and it's 12 feet long, minor is 6 feet long. Write another equation to model the second loop. All right, and then we were also told that the first one centered at the origin. All right, so I need a horizontal ellipse centered at the origin, and then an identical one to its right, and that forms a 8, a sideways 8. All right, so this is centered at the origin. They tell us that this whole thing is 12, so that means that part or half of it is just 6. All right, so for the first one, it is centered at 0, 0, and it is horizontal. So x squared plus y squared equals 1. All right, so major is 12, which means that green area, that green length is 6. So we have a 36. They tell us the minor is 6, so that means half of it is 3. And then we square that and get 9. And now let me do the other loop. All right, so for this other loop, we need to figure out where is this centered. All right, so if this is 6, then this also needs to be 6 if they're congruent. So that is 12 away from the origin. So this has a center of 12, 0. All right, so it's x minus 12 squared plus y minus 0 squared. And because they are congruent, I know they have the same denominators. All right, that is all for 10.4.